Hello and welcome. This is part 2 of a video series on basic Python programming, where I show you step by step the many different tools and techniques to this programming language. And I do this by building programs with you. So, continuing from the previous video, we have the basic skeleton of a calculator that can compute two values. And I left you off here with clues on how to continue. And a quick note on the if statements, which I touched on very briefly. You don't necessarily need these parentheses over here. And I'll get rid of one just to demonstrate that it can still work. It is really a matter of preference, and I happen to prefer having these, although in future programs, I may not include them just for cleanliness sake. So that's just a quick note for you there. Anyway, continuing on, let's go ahead and run this program, and we'll see I can do a 5 and I can do minus whatever number. Let's do a minus and a 4. I get the result. And right away, you may notice that there is there is an inefficiency to this program, simply because this variable is assuming that the operator, or rather the user, is going to type a minus sign every time. So if I did a plus, then it's not going to print the plus out. It's going to look for the minus, but if there was no minus, then we'd get an error. And I can demonstrate that here, where if I did a plus 5, minus is not defined, and that is true because it never entered this if statement. So we're going to have to fix that. And how we do that is by creating a variable that is going to be interchangeable regardless of what the operator is. I'll go ahead and change that to result and result. And over here, result as well. Let's test it out first with the plus or minus. 5 plus 4. Okay. And remember, I am using hotkeys here, so I'm doing Control S to save, and I'm hitting the F5 to run it. Now with the minus. Okay. Now we know that the plus and minus work. We can apply the same logic to the other two operators. I'll go ahead and copy that, which is a Control C. And now when I paste it, I'm doing a Control V. And one more paste. This will change to a star for the multiplication. And this will change to divide, which is the /. And here, of course, multiply, and this divide. Now we can go ahead and save it with a Control S, F5 to run. Let's do a multiplication test. 5 times 5, 25, perfect. F5 one more time, and we'll do 5 divided by 5, which is a 1. Great. Now we have a more complete version of the skeleton of a calculator. And now we're going to go more in depth into the if statement. Now you can see here that we have 4 if statements. And what this does is the program actually checks each one of these, no matter what operator you do. So for sure, it is always going to check this condition statement, and then this, followed by this, and finally this. And this is perfectly fine. It's perfectly legal, and there's nothing wrong with this. There is a different technique that we could use called the else statement. And how the else statement works is it would go into one conditional statement, check to see if it's true, and if it's not, it'll go into the else statement. And the else is also a reserved word. It'll appear orange there, and we'd have to do that as the syntax: if and else. And keep in mind, ignoring all these for now, just looking at these two statements, what this is saying is if the operator is plus, go ahead and compute this in the result. And then the else statement is basically saying everything else that is not plus, go ahead and do something here, whatever computation that we might want to do here. So the else is basically everything other than what this is or what this condition is. So you got to be very careful when you're using the else to make sure that you cover every scenario, and you want to kind of use else for after you've done and checked every scenario. And in this case, I'm only going to use else. Well, I can use else in every statement, but I need to add an if to it. And I'll demonstrate that in just a moment. Here, I could do if operator is equal to minus. Okay. And then we'll go ahead and do what we were doing right here. So now this will have the same result as if operator is plus, go ahead and do this. If not, then if it is this, then go ahead and do this. So this right here will have the same effect as this over here. However, this acts like a funnel. It will enter this, check it, and then go into this, and then check it. So if this is true, let's say, for example, that the plus is true, and it goes into the result, num1 plus num2, then it'll kick out of this entire condition statement, and it will never enter this else statement. In our previous build, without this one, I'll just go and delete it. Without that, what this does is, again, it checks every single one, no matter what. So like I said, the else is sort of like a funnel, where if you do this, it'll check this, and if it's not true, it'll funnel down to this, and if it's not true, it'll funnel down to the next one, and so on. But as soon as something is true, it'll get kicked out, and it won't go to the next one. And I can demonstrate that with a quick diagram where I have the original design, where no matter what, it's going to enter here, it's going to enter here, and it's going to enter here. It's going to check all three of them, and they're all going to be computed. And I'll just circle them to demonstrate that the program actually enters these conditional statements. But with the else statement, so if I start off with if, for sure this is going to run. And then I have an else, and then an if here, and then another else, and then an if here. Now let's assume, for example, that it actually enters into this else if, and this one turns out to be true, so it goes ahead and does, say, it prints a number of 1. Okay. So if this is true, then it checks it, it's done, it'll kick out, and then continue on with whatever it needs to do. So what the program looks like here, it'll go into this if statement, it check it, it's not true, go ahead to this one and run this one, check it, it's true, and it's going to print out that, the 1, kick out, and we're done. Which means the third else if statement never actually gets computed. It never gets checked. Whereas in the first design, all three of them get checked. Now, there may be instances in your career where you may find that, oh, I know for sure that there is only one condition that is going to be met, and I need it to be funneled down into a very particular scenario before I actually do something, and then I'm done. But if I'm not sure, perhaps there's a condition that may be met in two different instances, then you may want to stick with this technique. Now, of course, as you experiment and tinker with this technique, you'll find it easier to understand, and conceptually, you'll find it well, you'll be able to figure out when to use this and when to use this. So going back to our program, we know that there are only 4 possible conditions. There are only four possible operators that we can use, so we can actually funnel it down with a bunch of else ifs. And it's going to look something like this. However, this else and this if, Python allows us to combine these to make it cleaner to read, easier to read, and cleaner in general to program. So the syntax for that would be an elif, which is basically short for else if. So here, it's basically going to do an else if operator equal to minus sign. Go ahead and do that. And I'll follow the same syntax for the rest of them. Oh, I already have the minus, so I'm going to delete that. Here, elif for the multiply, and last one, elif for the divide. Let me put a space there, easier to read. I'll go ahead and save that. And tell you what, I will create a new shell. Okay, there we go. So let's go ahead and run that. Just test it with some simple numbers. Let's try a divide. 5 divide, sure, 6. And we have our result. So what this does is we're making sure that it'll flow either on this or this or this or this. And if at any time it satisfies one of these, it'll just immediately kick out and ignore the rest. So in this particular case, when I had a divide, it actually did have to check all of them before it reaches the bottom and then print the result. But if I had a plus, then what it would do is it would enter the plus, compute this result, ignore all of these guys, and go straight to the result. So that may be an efficiency improvement right there. Not much, but it is an improvement. So now that we have our program, oh, let me clean this indentation there. Now that we have our program pretty much good to go, and it covers all of our operators, we need to make sure that our program is robust. And what I mean by that is we want to make sure that it doesn't crash if a user, well, simply uses it. Remember, as programmers, we don't want to send a product out there that a user could find a way or figure out a way to make it basically crash. You know, we use products every day, and we get really frustrated when something doesn't work the way it should, or if maybe a sequence of events happens and it just causes the crash. It can be pretty frustrating. And we can take a look at this program and find several of these bugs. For example, if I type in an operator that is not any one of these, I could cause the program to crash. And I'll show you real quick. I'll type in F5. Okay, num1, I'll type in a number, and the operator, let's say I messed up and I instead put another number. And then num2, I'll do another number. And you can see, because the operator was not any one of these, then it caused my program to crash. And I don't want any of my customers to see this when they're using my program. So I'm going to have to account for every single scenario that could happen, say by this, in this case, by user error or by logic error. So So let's go ahead and fix this issue right now. And you might have guessed, we're actually going to use the else statement here to account for every other character that shows up that is not one of these four, and we're going to do something with it. So here we can simply do else. We'll just go ahead and do a print, tell the user invalid operator. Okay. This will basically account for anything that is not one of these operators. But it is still not enough because, okay, so let's say I do enter a 5 in the operator, it check, it's not one of these, and then it goes into here, it prints this out, but it's still going to try to print a result. And I'll demonstrate real quick. Same thing, I'll go ahead and do 5, 5, 5. You'll see that our invalid operator printed out just fine, but it still went into the result printout, which in this case didn't exist because it never entered any of these. So in order to account for that, we're going to have to create a flag. So we're going to raise a flag to say that, oh, this is valid, go ahead and print, or if it's invalid, avoid this altogether. And this is an opportunity for me to show you a new data type, what's called a Boolean data type. Boolean data type. And Boolean basically has two conditions, or rather two states, which is true or false. Okay. And how we're going to do this, by convention, typically Booleans have the is name in their variables. So in this case, I'll make it pretty straightforward to read. It's basically, if it is valid, go ahead and then go ahead and do something. If it's not, then do something else. So I'll go ahead and name it simply like this, is valid, and I'll set it by default to true. So what this flag is going to do is it's going to check to make sure that we have a valid operator before we actually print anything out. But if we don't have a valid operator, then I need to set this flag to false. And this is exactly where we're going to do it. So right after our print statement, we can do is valid equals to false. And of course, you might have noticed that the true and false are also reserved words, so we can't use these for variables. So now that we have our flag set to false here, we can use this in the bottom here in an if statement. So I'll go ahead and do if is valid is equal to true. And we want to make sure that it's indented, so it's part of the if statement. Keep in mind that that is part of the syntax. If we don't have the indentation, then it's going to give an error. So make sure we have an indentation there to show that this is part of the if statement. Okay, now we see if any of these are true, or rather if any of these happen, then this remains true. Therefore, this will be accepted, and this will go ahead and print the result. And on the flip side, if none of these occur and it enters this else statement, it sets this flag to false, and therefore this will never be entered and it won't print a result. And let's go ahead and test it out. Go ahead and hit Control S to save, hit F5 to run. Let's try it again. 5, 5, and a 5, invalid operator, and it kicks us out of the program. Perfect. Now, so that takes care of that. The other issue that we can find in this program, since we're dealing with a divide, we have to make sure that we account for this number here, which is the denominator. We know that we cannot divide by 0. That will cause the program to crash. So we want to account for this. As you might have guessed, this is another if statement. In this case, it's going to be what's called a nested if statement. What a nested if statement is it is an if statement within an if statement. So here we already have an if statement. And then inside this if statement, we're going to have another if. And we want to check if this num2 is equal to 0. If num2 is equal to 0, we can go ahead and tell the user print, let's say, error, divide by 0. Okay. And of course, we want to account for this too. If we don't do something here, no matter what, this is going to check, it's going to print this out, but it's still going to go ahead and compute this as well. And let me demonstrate that real quick. I'll do F5. Okay, I have a 5, I have a divide, and let's put a 0. And you can see it enters our print statement, but it continues on to the next line and tries to divide by 0 anyway. So in order to fix this, since we know that it's either this or anything else, so this is the only number that we care about, any other number aside from 0 is okay. And then in that case, we can use an else. So tap that out. Now we can try it out. And I'll go ahead and close this up, create a new module. So you can see a clean shell here. Let's go ahead and try divide by 0. 5 divided by 0. Oh, there you go. Again, I messed up. And this is good. We all make mistakes, and we got to learn by them. And this is part of the debugging process. So my mistake here was, yeah, I still, even though I accounted for this, which is perfectly correct, I printed it divided by 0, gives the error, but I didn't change the flag to false. So this is true. It's still true. It enters here. It's still true. Does all this. Still true. So therefore, this is going to be entered, and it's going to try to print a result. So, as you might have guessed, if we do enter this statement of divide by 0, we need to make sure that it is not valid. It makes the whole equation not valid. So we're going to have to put is valid equal to false. Okay, I'll go ahead and save that. Hit F5. Let's try one more time. 5 divided by 0. Perfect. No crashes. And we get our error message, and we're good to go. And that covers everything that we intended to make it more robust and make it, well, we just don't want to make it crash. And yeah, this will prevent the user from doing anything that may cause it to crash. And real quickly, just to show how this could work on the desktop version, or rather on the desktop, here's my program, the calc, and I'm obviously using the idle to run this, but you can actually run this on the desktop. If you double click on the calc.py, a little terminal executable will show up, and it runs exactly the same way. So I'll go ahead and do a 5 plus 4. But you may notice that it completely kicked me out. And the reason it does that is because it actually did print something, and then since there's nothing else after this, it exits the program and it's done. So in order to prevent that, if you do want to run it just from the desktop itself, you need to do a little placeholder here, and it's as simple as putting a little input. So I'll go ahead and call this exit. No, exit's reserved. I'll call it quit. Oh, that's also a keyword. So I'll just call it done. And I'll call it input. And I'll just say goodbye. Press enter to exit. That's pretty cool because I totally forgot that both exit and both exit and done are also keywords. So let's go ahead and save it. And now that I've saved it, let's try it out. I have 5 plus 5. Ooh, prints it out. And now we can just press enter, or any other key for that matter. We can just press enter to exit. And there you have it. Now, moving forward, we want to make this program more intuitive. I don't just want to do a calculation and then quit. I want it to be able to keep doing calculations until I say quit. Because right now, every time I got to come back to this program, I got to hit F5, do my calculation, and then goodbye, and then come back here again. So in order for it to keep going until I say so, I'm going to have to repeat this entire program over and over again. And this is where loops come in. And loop is a very handy tool in every program in order to automate programs so that they can keep doing what they're supposed to do until we say so. And for right now, I'm going to very quickly go over the while loop. And what the while loop means is that it is going to keep looping. In my example here, I'm going to keep looping this entire program until a certain letter or a certain input is met. So let's put a while loop up here. I'm going to, let me fix this here. I'm going to create a variable called again, and I'll set it to default y. Y for yes. And I'm going to simply say while again is equal to the letter y. So what this means is while this variable is equal to this, which it is by default, go ahead and do all of this. And in order for it to be part of this while loop, I have to indent this entire thing. I'll leave out the last input because that's just a placeholder for the program before it quits. Now that everything is indented, everything that is indented is part of this while loop. So if we trace what happens, we can see it'll enter this while loop. This is true. And it'll go through all of these processes and then finally give some sort of input. And then it's actually going to keep going on and on and on and on. So as a demonstration, this is what happens. So here I have 5 plus 4, and it's going to ask for num1 again, and this time I'll do a 9 times 4, and it's going to go on. And you can see where this is going. It's just going to keep going and going and going, and there's really no indication of how it's going to quit. So in order for me to tell the program to stop looping, I have to make sure that this statement is not true. So for right now, again, is always y. I'm going to have to ask the user to set this variable to anything other than y. In our case, we can just type in the letter n for no. And how we do that is here on the bottom, after it's done all of the stuff that we want to do, we can go ahead and do again and make sure it matches what we have on top again. And we're going to basically re-initialize this value with the user input. And I'll go ahead and do again and give the user a little hint, either y or n. Okay, I'll save that and I'll close this out and run a fresh shell. Okay, now we can do this one time and it's going to ask again, yes or no. For now, I'll just type no. I'll type n and it says goodbye. All right, perfect. And the last thing that we want to do for right now is to clean this up a little bit, because right now everything seems to be smushed, you know, one line after the other. I'd like to have these three in one section by itself, and then I want to have a new line to print the result by itself, and then followed by a new line to print the again, and a new line for the goodbye. And this is a new technique, and this is what's called the escape sequences. And this escape sequence is ignored as far as printing. It doesn't print out what you see, it prints out actually what you want. And in this case, we want a new line. So a new line would be an empty space after this num2. And what that looks like, and I'll demonstrate it over here with the result. So I want a new line just before the result after this number 4 here. And if I put a new line here, which is the escape sequence of \n, n for new line, it'll give us a new line just before the result. And I also said I wanted a new line at again, just before again, I should say, and a new line just before goodbye. Go ahead and save that. And I'll start a fresh one again, run module. Okay, I'll do it one last time. Here we go, much cleaner. And now if I say yes, it starts fresh from the bottom. And in fact, I kind of want this to be on its own. Seeing this enter num1 smushed with this doesn't look very good to me. So I'm going to go ahead and put a new line right here at the enter. So here I can put a new line there. Okay. Perfect. Yep, and there we have it. 4. Let's do a -8. Yep. And I'll do an n for goodbye, and that kills the program. All right. And this concludes the video for today. Next video, we'll go ahead and continue more loops. We'll go in depth into while loops, and we'll touch on for loops, and we'll also touch on how to format our output. Well, thank you so much for joining me in this journey of learning programming in Python. And I hope you're enjoying it. I hope you're having fun. And feel free to comment and leave questions for me. I'll be happy to answer it for you. Thank you and good luck.